I had a question for Math 126. 5.2 is the section, numbers 1 and 17. So I'll read it to you. I made some notes here on the paper. It says the half-life of radium is approximately 1,600 years. So I made the note that half-life of the radium is 1,600 years. And what a half-life means is if you have a certain amount, let's say 100 grams, in 1,600 years you'll have half of that, which is 50 grams. Okay. And it says determine little a so that capital A of t, now capital A of t would mean the amount of time t, you see that here, equals a sub 0, we call that a naught, that's the initial amount of the material that we had, of the radium, times little a to the t power. So we want to find out what this little a is. So in 1,600 years we're going to have half of the initial amount, a naught. That's what's going to be left. So our amount in the 1,600 years, 1/2 of a sub 0 is equal to a sub 0. So half the original amount is equal to the original amount times a to the 1,600. So we can divide both sides by a sub 0. And those are going to divide out. And we would have 1/2 equals a to the 1,600. We want to solve for a, so it's a to the 1,600, so we're going to take the 1,600th root of 1/2 equals the 1,600th root of a to the 1,600. Now the 1,600th root of 1/2, that's, by the way, that's 1/2 to the 1 over 1,600. And I put this in the calculator. Make sure you have parentheses around the 1/2 when you do that, and around the 1/16th. Equals a. So a is going to be 0.999567. Now part B says, okay, how much of a 1 gram sample of radium would remain after 100 years? So in that case, our formula is a of t equals 1, because that's our amount, initial amount, times 0.999567 to the t power. So we're talking about t being 100. So the amount after 100 years is 0.999567 to the 100 power, which is what? Oh, my calculator's still working on it. Okay, that's going to be 0.958 grams. And then it says how much of 1 gram sample would remain after 1,000 years. And that's going to be a of 1,000 equals 0.999567 to the 1,000 power, which is what? And for that I get 0.6485, and the book rounds it off as 0.648, so it should have been 0.649 probably, but there you go. And that would be number 1. Next question was number 17. Number 17 says Marshall invests $12.50 in a mutual fund which boasts a 5.7% annual return, compounded semi-annually. So it's got $1,250, 5.7%. Compounded annually, semi-annually. Okay. That means twice a year, by the way, n equals 2. This is after 3.5 years, Marshall decides to withdraw his money. How much is in his account, and how much has he made in interest from his investment? So the formula for this is the amount times t is the initial amount times, or principal. I think do we call it principal in this book? P, yeah. So we'll call it P for principal. Principal would be the initial amount. P times 1 plus 0.057 over 2 to the 2 times 3.5 power, because we're talking about time being 3.5 years. So the amount, I shouldn't say it time t. I'm going to call this, excuse me, I'm going to backtrack here and call this 2t. So the amount at 3.5 years is our initial amount, which was $12.50 times 1 plus 0.057 divided by 2 to the power of 2 times 3.5. Now when you do this power, make sure you have that in parentheses. So I'm going to put this in the calculator, 1250. I'm going to do a parenthesis, 1 plus 0.057 divided by 2, close parenthesis, caret button, parenthesis for the power is what I'm doing now, 2 times 3.5, close parenthesis, and I get 1521.74. That's how much money we have. So how much of that is going to be interest? Well, if you do 1521.74 minus 1250, excuse me, I get $271.74. So the interest is going to be $271.74. So what I did there is I subtracted the initial amount, the principal initially, from what we have. That gives us the amount that's interest. Okay. Hope that makes sense.